Today we're going to talk about section 5.5, the quotient rule, and integer exponents. Let's start with anything raised to the 0 power. Anything raised to the 0 power is 1. How about anything raised to the first power? Well, anything raised to the first power is just itself. Let's try anything raised to a negative power. Well, a negative power actually is not a negative number, but a reciprocal. So anything raised to a negative power would be 1 over that same thing raised to a positive power. How about 1 over anything raised to a negative power? That would be that thing raised to a positive power. What if we had a fraction raised to a negative power? It would be the same thing as the reciprocal of the fraction raised to a positive power, which we could then say is b to the n over a to the n. What about same base in a division problem? So a to the m divided by a to the n. This is a to the m minus n power. Just like when we have the same base in a multiplication problem, we add our exponents. When we have the same base in a division problem, we subtract our exponents. In common practice, I could do that. I could call this a to the 3 minus 8 power, a to the negative 5th power. Right, I could do that. I could call this a to the negative 5th power. And then I would have to rewrite that as 1 over a to the 5th. I tend to think about my quotients using canceling. So I have 3 factors of a on the top, 8 factors of a on the bottom. So 3 of those are going to cancel 3 of these, leaving 5 factors of a on the bottom. Again, if I had a to the 8th over a to the 3rd, I could say that's a to the 8 minus 3 power, a to the 5th, or I could say I've got 8 factors of a on the top, 3 factors of a on the bottom. Those 3 will cancel 3 of those, leaving a to the 5th on the top. So hopefully in the past you've learned it either as subtraction of exponents or some sense of canceling. So let's look at some problems. The question is, will this answer be positive, negative, or 0? Well, negative 3 to the negative 2nd power would be 1 over negative 3 to the 2nd power, which would be 1 over negative 3 times negative 3, 9. So it's positive. What about negative 3 to the 6th power without any parentheses? Well, that would be negative 3 times 3 times 3 times 3 times 3 times 3. So that would be a really big number, but it's definitely going to be negative. What about 1 minus 7 to the 0 power? Well, that would be 1 minus 7 to the 0 power is 1. 1 minus 1, 0. So there are some problems where we have to figure out whether it's positive, negative, or 0. Okay, how about is it 0, is it 1, or is it negative 1? Well, in a parenthesis, negative 10 to the 0 power. Well, anything to the 0 power is 1. So this is 1. What about negative 10 without a parenthesis to the 0 power? Well, that's the same as 10 to the 0 power, 1, with a negative sign. So negative 1. What about 0 to the 5th over 5 to the 0? Well, 0 to any power would have to be 0 because it's just 0 times 0 times 0 times 0. So that's 0. 5 raised to the 0 power is 1. 0 over 1 is 0. Okay, so let's evaluate some problems. So we have 5 to the negative 4th, which would be 1 over 5 to the 4th power, which, believe it or not, your text thinks you know. 5 times 5 is 25, times another 5, right? 5 times 5 times 5 times 5. Let's see. 5 times 5 is 25, and 5 times 5 is 25, and 25 times 25 is 625. So this is 1 over 625. What about 2/3 to the negative third? Well, that would be, I could do this one of two ways. I could either do it as 2 to the negative third over 3 to the negative third, and then say, oh, well, that should be 3 to the third on top and 2 to the third on the bottom, which is 27 over 8. I could do it that way. Or I could say, oh, well, this should be 3 over 2 to the third, right? The reciprocal, which would be 3 to the third over 2 to the third, which would be 27 over 8. So either way, the answer is the same. This is a very weird problem. 6, let me move this out a little bit. 6 to the negative first plus 2 to the negative first. Well, 6 to the negative first is 1 over 6. And 2 to the negative first is 1 over 2. I'm adding. Oh, so now I have to have a common denominator. 1/6 plus 3/6. So 4/6. This is 2/3. Okay, let's keep going. 4 to the negative second over 4 to the third. Okay, I could do this a couple of ways. I could do this as 4 to the negative second minus third. So that would be 4 to the negative fifth, which would be 1 over 4 to the fifth. Or I could do this, so this is one way, or I could do this as 1 over 4 to the second. 4 to the third is already in the right place, so this is 1 over 4 to the fifth. This one would be, I really only have one way to do this, 3, and the x to the negative eighth should actually be x to the eighth in the numerator. How about, let's see, x to the negative eighth should actually be x to the eighth in the denominator. And y to the fourth is just going to stay. There, done. What about this? Well, 5 is just to the first power. That's going to stay. And x to the negative seventh, pardon me, should actually be x to the 7. So that's done. Okay. Well, I could do this as, because I've got common bases, right? Base of 3, base of y. I could do 3 to the 8 minus 10, y to the 5 minus 2. So then that would be y to the third stays, 3 to the second goes. Or I could use my canceling strategy. I have 8 factors of 3 on the top, 10 factors of 3 on the bottom. If I cancel as many as I can, I'll still have 2 factors of 3 on the bottom. I've got 5 factors of y on the top, 2 factors of y on the bottom. If I cancel as many as I can, I will have 3 factors of y on the top. And if I'm really good, I will acknowledge that I know 3 to the second power and call my answer y to the third over 9. Okay, in this case, these are not the same base, but these are just numbers. So 10 divided by 2, that's 5. I've got 6 factors of p on the top, 4 factors of p on the bottom. These 4 are going to cancel, and I'm only going to have 2 factors of p on the top. 4, 10 divided by 2 is 5. P to the 6 minus 4 is 2. I'm done. Okay, this is our day 2 problem, so I'm going to stop day 1.